This is the Empower Podcast. Released August 21st, 2022. Episode 600. The Custodial Arts.
Welcome to the Amp Hour. I'm Dave Jones from the EE Vlog.
And I'm Chris Gamble of Contextual Electronics.
Oh, you sound perky today.
I've got some deep voice. I got some bass in my voice today, and this is still the usual recovering from. Basically, I'm going to daycare. This is
right. Okay, yeah. Say that more.
Basically, like I go to daycare as much as my daughter goes to daycare.
Yes, exactly. Yeah. Welcome to parenting.
She just kind of shuttles at home, and I'm like, oh, thank you, daughter. That was very kind of you.
Yeah.
And
right.
So I spend my weekends now. It's pretty cool. It's pretty cool, Dave.
Good stuff.
I mean, it's fantastic. I really like being a parent. It's great.
Told you.
Yeah, totally.
It's pretty good value. Well, that's
I mean, what else am I going to do?
Exactly. Yeah. What do you want to design electronics for your life, or do you,
Nah. Design humans.
Right. Okay. Yeah.
She has picked up piano, but no electronics yet. So.
Okay. Right.
Yeah.
Cool. I had a youngster in the lab the other day.
I saw that.
Yeah.
I had a thought about that. I was thinking,
right.
Before long, Dave's not going to have to hire an assistant. No more David 2. It's just Sagan 1.
Right.
So he was helping on the troubleshooting of the BOMB project, right?
Oh, well, yes, he was. That was not what I was referring to. I was talking about the winner of the scope.
Ooh. Oh, really?
Turned up to the lab and actually picked it up in person. 13-year-old kid, yeah. And you'll see him on the next mailbag video. So
nice. That's great.
Stick around. Yep.
Man, that's winning a scope at 13 would be like very
that'd be like I know.
I
could only dream about
cool.
it. Yep.
Yeah.
So it's awesome.
Back then, you winning a scope would be like winning the lottery, basically. So.
Oh yeah, I know. It's incredible.
Yeah.
But so that's why I very deliberately gave it away to a young kid. I said,
great.
there was a lot of people who were university students entered and stuff like that, but it's just not the same, right? This kid's actually designing and selling his own boards at 13 for the framework laptop-y thing.
Oh, cool.
Yeah,
I didn't know the whole context here. That's great.
Yep. So
Framework Laptop is the open source one, right?
Yeah. Yeah, exactly.
Yeah, I think we've mentioned it
so it's got
here.
open source interface things, which is a USB-C little modules. It's got like 4 of them, I think, on there, and you can just design your own. So he's designed these little USB-C modules that plug in and convert it to RS-232 and convert it to Ethernet and other things.
Awesome.
So
yeah.
It's
cool.
great. Yeah, so they even gave him a free laptop as well because he's actually developing boards for them. So which is really cool.
That's great.
And to do that at 13 is, hats off. So that's why I gave him the scope. So
cool.
Yep. Anyway.
What does he use for layout, though? That's the real question.
Oh, right. Okay. Well, I didn't ask. Sorry.
No, it's okay. It's not polite. It's not polite to ask,
Right. Well, I doubt he's using Altium. Let's put it that way. And if you're not using Altium, you're probably using KiCad.
Kids cracking codes
cracking
these days.
Cracking the codes and okay.
Yeah.
Yeah, all these young kiddies.
Yep.
Super smart. Boy. But Sagan was here and he was helping with the debugging because he was like, he was happened to be hanging around the lab and I thought, we'll shoot a video. And
that was great. I was thinking I bet he's better at electronics than I am at this point.
Right. Well, he does practically no electronics. I know that's sacrilege, right? But he knows some basics, but, he's got other interests and stuff, right? So I don't push it. It's not like he hangs around people think like he hangs around the lab all day, every day. And, that doesn't really happen.
That's probably the best way to get a kid to not want to do something.
Right. It's just to hang around the lab board, so. Anyway, so he was quite excited to help me with a video. And, of course, I'm trying to use the Roden-Schwartz scope, right, which is very, it's quite an advanced, touchy-feely scope, right? It's got all the whiz-bang stuff.
Was the power supply, right? Wasn't it, or was it both?
Huh?
Oh no, you had a scope and a power. What was that power supply? Because you had a.
Oh yes, that was a Roden Schwartz power supply as well. So I was using the I was using the fancy pantsy Roden Schwartz power supply, and I goofed that up. Then I was using the fancy pantsy Roden Schwartz oscilloscope, and I goofed that up. And Sagan picked up a thing. He said, "Oh no, here it is. It's it's already set there." In that, like, and I'm just like, so you can see
Dave,
that
we're the
in
olds. We're the olds now.
Well, that's the thing, right? Because I've got so many freaking scopes here and so many different instruments. I'm always using I'm not using the same one thing every day. So I don't get used to it.
You don't have to
and it
be
confuses
defensive,
me.
man. Nobody.
I know, but it's
don't
just,
blame you,
I find
my
it
friend.
annoying. I find
sure.
it personally annoying that I don't know how to use my own scopes because I'm constantly swapping back. I don't just pick one. Like, I'm constantly using different ones.
Sure.
Just lying around, and it's
Well, you don't usually pay for them, so like that's
I know. Well, yeah.
Usually when you pay for them, you read the manual.
Yeah,
you get some training,
and you
maybe,
get to you spend a whole week just digging right down, and it becomes second nature. It becomes like a reflex action. You know exactly where every knob is.
One scope as well, right? I mean, if you just have your daily driver, then that's like what you use.
Exactly.
I only know mine because actually I have some scopes I don't really know that well.
What scope have you got? What is your daily driver?
I've got my ancient MDO 3000. I should.
Oh, you use that as a daily driver?
No, that is not my daily driver.
Oh, I was going to say that is painful as it's a nice high-end scope, but it's painful as a daily driver, slow as a wet week.
Yeah. No, I mean, I've got honestly, you know what? You're not going to like this one, Dave.
Oh, okay.
You're not going to like this at all.
Why?
It's my Analog Discovery 2. I use a PC-based scope with a plug. Like that's all I. That's
if it works for your form factor, if it works for your form factory setup thing, then that's fine.
Yep. And I mean, most of the time, like I'm not. I mean, I'm doing so little electronics these days too. I'm doing more code and stuff like that. And if things are going that wrong, I'm usually kind of working my way up. Right, there is no daily driver at that point. So
got it. Well, if I'm over on the repair bench, I've got one of those National Instruments, virtual bench things.
Oh, the
one of those
PXI?
No, it isn't PXI. It's the benchtop unit.
Oh, I know what you're talking about. Yeah.
So you plug it in via Ethernet.
And that is kind of like a really, really fancy analog discovery.
That's a really, really fancy analog discovery. Yeah, a very expensive analog discovery. And, so it's got the scope, it's got the spectrum analyzer, it's got the multimeter, it's got the function gen, it's got the logic analyzer, it's got, everything built in. So, yeah.
See, this is what I use, like your forum's great. And there are some very, very technical people on there, like really talking about deep technical, like equipment stuff.
Mm-hmm.
But I can't lust after something that has 8.5 digits because the last time I needed something with 8.5 digits,
yeah, exactly.
I lived in Cleveland, and it was because I was working at a test equipment company. Like I just don't, I don't have that need in my life, and so that's fine.
Got it.
That's great. I'm just not going to spend the time on that. So
yeah, totally.
That's part of it. What is the NI part, the tool thing called? Multi-tool?
It's the National Instruments Virtual Bench. I think it's it's Virtual Bench.
Sure. I remember talking about when you got it.
Yeah.
I don't know. Yeah. I mean, we all get used to our setups, and
yeah.
I need to work mine out. I have some hardware revs coming up. I sent you some of my hardware just got published about because my talk came out from Zephyr Developer Summit. My good friend Mike Stish and I, former Hackaday editor and current coworker, we gave a talk about Zephyr and hardware that we built. Mm-hmm. And it's got some pretty pictures built into this PCB, and that's about the most technically advanced part of that board.
Right.
There's a lot of headers, and
it's basically a daughter board kind. It's basically a motherboard kind of thing that just interfaces other boards that plug on. I can see a power supply on there, and there's not much else.
Yeah, power supply, bunch of headers. Click standard, quick headers, stemma, like all these different names. What's Grove is the seed one.
Yeah.
Terminal blocks, just kind of little everything to try and just plug in any sensor, and it's it works fine.
Yep. And this is just an industrial looking demo you can take on the road to show potential clients and stuff, right?
Yeah, this is what I took to trade shows when I was going to those, that sort of thing. Painted cases and pretty faceplates and stuff like that.
Nice.
Yeah, nothing compact about it. I showed it to one of my friends, and he's like, "Whoa, that is so big," and I was like, "Yeah, it really is not small. It's
right. No, well, you don't want small things for like demos. You want large, like things you can put on the. When you go into a boardroom, when you go into a boardroom to pitch something, you want to put something substantial down, not just a little piddly little thing you can hold in your hand.
Unless you're if you're a dev shop and you're talking about your capabilities to make things super small, then I'd say you hand them, this little coin cell looking thing, and then you
Totally.
on the screen you put the huge close up of it. And you're like,
exactly.
this
That's
is what
it.
you're holding right now.
Yep.
But yeah, no, this is more of a kind of look at the shiny lights and the artwork on it and that sort of thing. So
Got it. The thing in the middle, at first, the big G in the middle, which I assume is the Goliath logo that you've done in copper there, or gold, gold plate.
Yeah,
gold
plated,
flash. I thought that was a touch button at first, but it's not.
Oh, that's a great
I don't
idea.
think it is.
It is not. No.
No, right. Yep.
Yeah, there's no cap touch on this thing because there's really not that much intelligence on the faceplate. So what Dave and I are talking about is there's a top plate that's with standoffs, and that's got artwork on the back side of it. There's some components on the back of it, and it's really just like a port expander.
So you've got some switches on the top. So you're basically doing a PCB front panel with some LEDs. Are they reverse LEDs or are they mounted on the top?
They are on the top. Yeah, they're just real tiny, kind of built. They're kind of surrounded by silk so that you kind of don't see that. You could.
You don't sort of see the solder joints. Yeah, you just sort of see the LEDs. Yeah.
Yeah, and there's actually no traces on the top side. I was pretty proud of that.
Yep.
It's all just it's a 2-layer board, all just flat copper.
Yep.
And even the vias then are also covered by silk to try and hide those too. So when there are vias, make sure they're under silk.
So you've got solder masks. So you've got tented vias, and then you've got silk screen over the top of that, just to make sure,
just to make it kind of uniform, And then there's logos and artwork I put on there, that sort of thing.
Right.
But this is a really simple board. Like I said, it's just, so there's remember I was talking about flat flex about probably 6 months ago at this point. You and I were talking about flat flex a bunch. So this is the flat flex thing, basically going from the baseboard at the bottom up to the top board. And that's just got I2C, SPI, power, reset, interrupt.
Yep.
And so that you can basically talk to an I2C device in the top, and there's a little tiny, display and port expander. And that's really all it is. So there's really not much going on there.
Right. Got it.
Yeah. So
cool bananas.
It's my baby. And the rest is boring.
And you're going to rant about the feather, apparently.
No, I wasn't going to rant about it. I was going to discuss it. Yeah. Yeah, no, I mean, so so this is, like I said, the Adafruit helped share this post, which is really nice of them. I've been using, so I put feather compatible headers on this thing because I really do like the ecosystem. There are some limitations around it. Probably one of the biggest limits. So there's 2 limitations that have gotten me a couple times in a row. One is power coming in. It only comes from the USB plug. So Dave's staring at this right now. So people have to click on.
It doesn't come from the header? You've got no power pin on the header? Really?
Well, there are power pins down to the header, so you get 5 volts coming in. That's what they expect.
Yeah.
And this is how there's a standard that they wrote as well. And it's not like a super hard standard, but they wrote it enough so that it's pretty uniform. I think across the boards, definitely across the boards that Lemoore and Phil make, and a lot of the partner boards as well match it. So 5 volts comes in. Usually, they expect it to come in over the USB-C or the USB micro, as shown on the board that Dave and I are staring at, and then basically that goes through a protection diode, and then that goes to charger circuit for a LiPo. That's I think one of the best things about the Feather standard is a 2.2 millimeter JST header off of that thing. So it's kind of like a standardized battery power thing. And then normally there's then a buck converter to take that LiPo down to 3.3 as a standard there. I think some of the boards might have 1.8 rails as well. But if you want to then so then it also exposes the USB 5 volts to the baseboard pins, right? So again, to try and draw a picture for people here, there's a USB connector. There's 2 rows of pins that are 0.8 inches apart from one another that you could plug into a breadboard. There is a 5 volt pin that goes down into the breadboard. Okay. But that's actually behind the diode, right? So that's so that you don't back power the USB port from your board. It's only supposed to go from the USB port down to the 5 volts. So I totally get why they're doing this stuff here. Let me just be clear about that. But that means that has a couple implications. One is your 5 volts is actually usually more like 4.4 volts, right? Because you got the drop on a Schottky diode.
Exactly.
2, you can't back power this thing. And so the board that we're looking at in this photo is actually a non-standard board. This is from Actinius.
I was going to say, you just solder blob it. You just mod it.
Yeah, you could solder blob it, but they actually, so the Icarus that's shown here, it's actually a cellular modem on here. They actually take one of the extra pins, which is on the far right of the board, and then they say, actually, you can put up to 20 volts on this pin and back power this board because that's going to go into our buck boost.
All right.
And so the 20 volt pin is also then another diode ORed into that power supply.
Right.
So basically now you could power it off this 20 volt pin, you could a VIN pin really, the 5 volts in from the USB, and then if both of those power supplies are gone, then there's a P channel FET that then kicks on the battery to start back powering the circuit as well, which is pretty seamless. So that's a really simple circuit that Limor puts on all these boards, and it's really effective. It's like very, very effective if you look at one of the schematics.
Got it.
So yeah, I mean, it's like I said, generally as the standard, that's great. It's just the lack of back powering has been limiting for me. I think that expectation.
Yeah, no, fair enough. Totally. Yep.
Yeah.
Yep. So what's the processor on this Feather? Like you can tell I really don't know anything about.
Yeah.
I don't follow these embedded pros. There's just too many of them.
Yeah. There's so many. Yeah. So the one that we're staring at right now, so Dave and I are staring at the Adafruit post about this. It's the NRF 9160. That is a cellular modem. It's a dual core M33. It's got trust zone and it runs Zephyr. And so you probably heard me talk about Zephyr. This is like my cellular go-to. So there's 3 current Feather makers that do this. So Actinius does this. Jared Wolf from Circuit Dojo, he has a version of this. And then SparkFun licensed the Jared Wolf board. Jared's a former guest of the show. And there's a SparkFun version now as well. And SparkFun comes to my second gripe, which is just generally the smallness of it all. Yep. If you notice on the one that we're staring at, there's a 6-pin tag connect header. And the SparkFun one extends it just a little bit. And then they fit a 10-pin SWD header on there for programming and debugging. And that small difference really makes a difference for usability. It's kind of insane how much that makes a difference from like not having to have a tag connect plugged in all day, every day if you're doing debugging and stuff.
Got it.
So
cool.
So we'll link photos. Obviously, we're talking about photos of things, so that always sucks. But
right.
We'll link stuff in.
Okay, so that's an ESP8266, is it, on the Feather?
No, the Feather, the one that we're staring at is the NRF 9160. That's a cellular modem. ESP8266 is a Wi-Fi modem.
So they've got different versions of the Feather.
So the Feather is just the form factor. So all it is, if you look at the standard,
it's just the form factor.
That's right.
Oh, yeah. Okay, right.
And like I said, there is a standard. We'll link that in too.
So it's just the dimensions and the pin out.
That's right. Yep. And so you see that there's mounting.
And the actual functionality of the pins, like they define, like you must have. So you have to, if you're designing a Feather compatible thing, you have to not allow that back powering to happen? Is that?
So the back powering is kind of a loosey-goosey pin. So like if you look, so like I said, I mentioned two cellular board makers, right? So it's 2 people making similar products with the same SIP or chipset on it, right? So Jared Wolf's Circuit Dojo and Actinius Icarus, they do it for different reasons. So Jared focuses on like super low power. And so that's like a low power cutout. So if you're trying to like get like the lowest power possible on a cellular board, that's what Jared uses that pin for. Actinius uses it to have this back power capability.
Okay.
And so if you wanted to power this board in production, you could do that from this pin and, maybe off like a 12-volt industrial supply. So kind of like you could see how they're targeting even different industries. Like Jared's like almost targeting having this in the field on just battery power. Actinius could play a little bit nicer in like a industrial setting.
Gotcha.
So it is like a really flexible, kind of like a Nouveau Arduino style header with better pin spacing.
Yep.
Like consistent pin spacing and, fewer pins. That's another general, that's just generally a limitation. Like this Nordic SIP probably has 30 unused pins underneath the package.
Yeah. So, yeah.
Yeah, so there's always that limitation, but it's really just a prototyping platform, right? So
sure. Then
eventually you're going to put it down and you might get some other stuff out of it. So
got it.
Yeah.
Cool bananas. Okay, right. So it's just a hardware standard. I thought it was a yet another interface.
Yeah, let me send you the standard page actually, just so you have that in front of you. So this is Feather specification. So this is, I'm not sure if this has been updated at all. I'm not sure it needs to be updated, but I remember like when they first started publishing this and like, they're like, basically, Adafruit's like the market maker in this case, right? They do whatever they want and that's what they should do. They sell so many boards. It's just like, okay, they're just going to build what they want. And then other people have kind of glommed onto the standard, but that's kind of how it goes too with, like you think about ad hoc standards like this, right? There's no standards board or anything like that. It's just Lemore coming up with this, and it's a good form factor for them, and other people are like, yeah, that works for us too. And then you get kind of tapped into the ecosystem as well.
Sure.
And so if you look at like the particles, like an IoT system, they actually sold boards that also use the Feather form factor. Blues Wireless, another IoT system, they also use the Feather form factor. And if you look on the right side, you could see all the ones you can buy with different chipsets.
Yeah. No, there's tons of them. There's Atmels, there's ESPs,
Yep. That's right. Yeah, and so I found the form factor actually to be. I've used this in some other prototypes before. They have like a really nice OLED screen that plugs into this, and so like that's been great. So basically, then I kind of turn the whole thing on its side. The screen is plugged into the top. You put headers on it. Your screen is plugged into the top. You turn on its side, and then you kind of have like an ad hoc, like little display off the side of this thing for troubleshooting or for displaying for a customer, that sort of thing. And then you just design a case around it.
And then you use whatever software ecosystem supports whatever processor you've got on your feathery thing.
That's right. Yeah. So like for example, like the NRF 52840, right? That's another Nordic chipset, but for Bluetooth. And that you could use Arduino, you could use CircuitPython, you could use, I think Rust even targets it now. You could use Zephyr, you could use Embed, you could, and these are, a mishmash of like ecosystems and real-time operating systems and stuff like that.
Got it. Speaking of Nordic Semiconductor, this was quite voted up on the Reddits. I guess a lot of people care. Nordic are now into Wi-Fi. See, we talked about this briefly before the show, and I just assumed that they already had Wi-Fi things because I actually equate Nordic Semiconductor's processors with wireless, right?
With wireless, yeah, but there are many types of
that's
wireless.
only Bluetooth, right? Apparently. So they haven't had a Wi-Fi one before?
So they also have cellular. That's what we were just talking about.
Cellular.
That came out about 4 years ago, I think.
So I just assumed that they already had a wireless thing, but that's
I think that's a very
Wi-Fi
fair assumption.
Yeah,
I like the new part number because it's like, wait, is this a FET? It's an NRF 7002. Is that like a N-channel FET?
It sounds like a FET. Yeah, exactly.
Yeah, but it's actually, I think it's actually because the early Bluetooth chips they had developed. So to go backwards in time, they're currently on the NRF 53. That's a 5340 rather. That's like a dual core Bluetooth chip. That's going to be in all your new headsets and wireless earbuds, stuff like that.
Yeah.
NRF 52, that's the one that I've talked about a bunch. I just mentioned it actually. The NRF 52840 is one of the chipsets that was on the ABC board, the one that I made a while back. Very, very popular. That's on the different families in there are like in just you were surrounded by them, like literally surrounded by them. 51 was before that, obviously, but then prior to the NRF 51, they didn't have any processors inside the chip. It was just a peripheral. And I think that was the NRF 5000. And I think this is the same thing where this is a Wi-Fi chip, but there is no processor inside of it. So it's just acting as a peripheral. So you have to have something else driving it, like a NRF 9160 or a 534. So
what's the big deal?
Well, the big deal is that they entered an entirely new market is one thing.
Wi-Fi, woo, groundbreaking.
Well,
sorry, I've got to I mean, how many Wi-Fi solutions are there out there?
There are many at varying price points. That's probably one of the big things is price points. Integration levels is another thing. Like how much is integrated into a SOM versus a SIP versus a whatever the other package names are.
Got it.
They are entering a crowded market. This is they're targeting Wi-Fi 6 first, which is supposed to be lower power. Everybody's moving to Wi-Fi 6. I don't know much about it yet, to be honest. It just came out the other day.
Right.
But it's
got it.
Yeah. I'm excited about this because I've been using their cellular board, the Thingy 91 and the NRF 9160 DK, to work on asset trackers, right?
Got it. Yeah.
I can ping a GPS. I can turn on a GPS modem or whatever you call it. I guess. Yeah, GPS modem. Is that right?
Yeah.
They have a GPS modem internal to it.
We will run with that.
Okay. And so there's like a dual front end on that 9160 on that cellular board. So it uses sometimes it's cellular, sometimes it's listening for GPS, and you can do both. And that's pretty cool. But it's really power hungry to sit around waiting for a minus 120 dB signal.
Yep.
And you have to have really, really good antennas and all that kind of stuff. And so much like our phones, the fastest way to figure out where you are. Do you know how our phones figure out where we are most of the time?
Well, that's part of the GSM triangulation-y thing.
Yeah, that's another way to do it, but that's actually really rough too, right? So you could like ping a tower. You could say, "Oh, I see 3 towers.
Yep.
Here's where I am roughly." But that's only like 10 to 20 meter accuracy. The most accurate, not the most accurate thing, but the easiest accuracy thing you can do is you turn on. This is kind of creepy, actually. You turn on your Wi-Fi.
Yeah,
and you say, "What networks are around me?" And then you send it to Google, and they say, "Oh, exactly. I know where you are."
Exactly.
Holy shit, man! Like that's crazy.
I know. Yep.
That's like, and our phones are just always doing that kind of thing. And so that is now going to be enabled for Nordic too.
Got it. Okay.
Yeah.
So it talks to Big Brother, and Big Brother knows where you are. Great.
I mean, yeah.
It helps that I'm currently reading George Orwell's 1984. So
you are interesting. What is the impetus for rereading or reading?
Oh, rereading. Yeah, I haven't read it for a long time, so I thought I'd reread it. And yeah.
How's it read? I mean, does it hold up?
I'm only just started, so it's okay.
Yeah.
Yeah. But it's more the implication of it than the actual book itself. Okay. I think it's, it's all the predictive power of it, and
sure.
Yeah.
Yeah, but I mean, like, we're not all drinking gin, right? Isn't these like the main characters like drinking a bunch of gin?
And we're living in Oceania.
Is that what it is? You live in Oceania.
Wait, I do. So, yep.
Yeah, see, well, you let me know how accurate it is. I don't think you're a gin drinker.
No, definitely not.
Yeah.
Yep. Anyway, all this high-tech bullshit, I've been low-tech in the last day. Yeah. I was working on discrete TTL stuff.
Oh, okay. So what did you decide? So on the BOMB project, you're going to do TTL?
I'm going to show you how to do it. I don't know if I'll actually build it up.
Okay.
But I think because it's actually surprisrisingly complex to build. Like all I want is a countdown timer, right? A simple countdown timer. Oh my God. So, the first thing I thought when it crossed my mind, you've got a LED display, which you want, like 7-segment LED display you want to drive, and you've got a counter. Bingo, the CD4026, right? The classic 4026. You probably have no idea what I'm talking about. But when I was a boy, I built so many clocks and stuff using the CD4026. And we can link in my video of a clock I built when I was a kid.
Okay, great.
I've done a video on that and uses 4026. It's really nice because it's got a decade counter built in. And so it's a decade counter. So it doesn't count to like 16. Like it actually counts to 10. Right, so that's what you need for digits, right? So it's a decade counter, not a BCD counter. So it's a decade counter, counts to 10, perfect for digits, right? And then it rolls over, and then you've got a carry which goes to the next one, which so great for counting situations. And it's got a built-in 7-segment decoder as well, so it translates the decade counter output, the BCD output, to 7 segments, and then so you can drive your LED display directly. So it's all built into one chip. It's really quite nice.
That's nice, yeah.
And but that can only count up.
Oh.
Right? I need to count down, right? You can't force it to count down because there's no latch input capability.
Well, couldn't you just make the power supply negative and then it goes down?
Right, yeah, of course, yeah. Or use it down here in Australia and it counts backwards.
And that's right, right. Turn upside down.
It's just automatically. Or you can feed in a negative polarity clock and it counts backwards.
Right.
There's the trick. So so that's annoying. So it forces me into, like, I can't use that sort of semi-integrated chip anymore. I've got to go to like a regular decade counter. So I need a decade counter chip. Then I need a decade counter to BCD. So I need a BCD decade counter. Then I need a separate 7-segment decoder chip. And it turns out I need like 3 chips for each segment. Right, so I'm at 15 chips already, right? I'm at 15 chips already just to do this countdown timer, right? And this is just the drive-in, counting latch-in stuff, right?
I'm just imagining like a game show right now, like da-na-da-na-da-na-da-na. How many discrete logic chips will it take for Dave to switch to a microcontroller?
So
Da-na-da-na-da-na-da-na.
So I'm currently at 15, and that doesn't include any clock stuff, doesn't include any other gating or anything like that, because you need, blanking gating. So you need to, and then I need to gate the clock, which goes to it, because it's like you shift it in the data, and you don't want to be shifting in all the time. So you only want to like shift it in, once a second or something like that. So you've got to have some gating logic and some clock logic with different speeds. And, so we're looking at like 20 chips or something just to do a countdown.
When you said there's 3 chips per
segment, per digit. Oh, sorry. Does this have 5 or 6 digits? I think it has 5.
It is 5.
Yeah, 5. So there's at least 3.
But the thing I'm not sure about, does each segment get its own counter? I would figure there'd be a centralized counter.
Yes, each segment gets its own counter, because you have to keep track of your count, right? You can't like multiplex the counters. You've got to keep track of the count for each digit.
Got it. So when each digit rolls over, then that triggers the next one down the line.
Exactly, that triggers the one down the line, and and any good decade, any good counter chip will have a output, which goes on to the next one. So it actually cascades. It's got a cascade output. You can actually take the 7 segment, like the last digit output, and then feed it. But a good one has a carry, then it's got ripple carry, and it's got blanking enable and all sorts of stuff, and latch in. And
well, I'm sure that like most of these chips are available in like BGA packages, so you could probably fit them all in there, right? I mean, that's.
Oh, it's not like size isn't a problem. It's just the sheer number of chips.
I'm just making a joke, Dave. Nobody's making BGA TTL stuff.
Well, you can get some really tiny ones, which is annoying.
Yeah.
When I was a boy, it was dip or nothing. Yeah. Anyway, so
you
so it's like
wire wrap this.
Wire wrap. Yeah, I'll go. I don't even have a wire wrap gun anymore, or a tool.
Yeah.
I don't even have one.
Man.
Yeah, those were the days. I wasn't really a wire wrap man myself. I wasn't really a wire wrap.
No, point-to-point drag solder.
Yeah, just point-to-point wires. Yeah.
Yeah. Got it.
You'll also be able to see that in the video that I built as well.
What's it going to take to get you into like an 8-bit microcontroller? Because it would be like a single 8-bit microcontroller.
Oh yeah, no. Yeah, I could do this with a 3-cent one of those 3-cent microcontrollers.
Oh yeah, that'd be fun. Yeah.
In a SOT 23.5.
Yeah.
In a SOT 20, I think it's available in a SOT 23.5, isn't it? I don't know. I've got a whole bunch of them somewhere.
So like one of those plus some shift registers and you're done, kind of thing.
No, you wouldn't even need the shift registers. It'd just be the micro. You
drive it directly from the micro?
Because it's actually, because ultimately you want a serial output. See, because we've got a serial, to drive the board that I've got, it's a serial input, right?
Oh, that's right. I forgot there's chips on that.
Yeah, so I've got to have all these counters, which then go into shift registers, right? And then you've got to shift register that out to a single bit stream, right? So I've got to convert 5 digits counted. This is why I need 15 chips minimum. Right? Because I need a decade counter, I need a BCD to 7-segment decoder chip, and I need an 8-bit shift register. And then I've got to cascade all those to get my individual bit output, right? So it's like,
this doesn't sound fun to me.
No, right? It's not, but it could make for an interesting video, and it's a classic example of or like here's like a 25 chip design I was forced to do using discrete TTL. It's replaced with one SOT 23.5.
What if you just like you were designing like the board for this SOT 23.5 microcontroller, and you're writing the code, but the whole time you like had like, that like water drip torture. It was like doing that because this sounds like torture, what you're talking about.
Right, but this is how things were done in the old days. And if you see any of my, teardowns of vintage products, that's why they're in big 19-inch racks with these huge cards on them. And they've got hundreds and hundreds of TTL chips on them, because that was the way to, you do it. Look, if you wanted to get fancy pantsy, you get a PAL device or GAL. A PAL or GAL device, which could integrate a whole bunch of discrete logic, right? So, but goodness, all right, this is before CPLDs and FPGAs came along, right? You'd have GALs and PALs, and a 16 V8 or something like that. Do they still? Can you still? I'm going to check. DigiKey, can you still buy like a 16 V8?
16V8.
16 V8, I think, if my memory is not. Embedded PLDs, 25 items. Yeah, a 16 V8 is showing up. GAL 16 V8A. Yep. Stock. There's marketplace stock, no DigiKey stock. It's like,
get that out of here. Get out of here, DigiKey, with your marketplace.
Marketplace bloody stock. Yeah, it's pretty annoying. Yeah, but anyway.
I'm going to put like the most ridiculous things I can. Yeah, they already have ridiculous things on DigiKey. They have toilet paper and
do they?
Snow shovels and
really?
Yeah.
Oh, seriously?
Yeah. Search for some S tickets on there. Yeah.
No. Well, they know. No, I don't see it. I put in toilet paper and I don't get anything. Or is it called toilet tissue or something in America?
Yeah, I put in like Cottonelle or I don't know.
I don't know those brands. Right.
Yeah. You got that fancy down under. You got some down under paper for your down under.
We would call them bog roll. There it is. Janitorial and maintenance products. They have a whole section of industrial supplies of janitorial and maintenance products.
Mm-hmm.
Oh, well, I guess they had the same thing at Farnells and RS, but anyway. Yeah, the bloody marketplace thing. The reason I go to DigiKey is because I want DigiKey stock. Right? Yeah. That's but I guess if you're a buyer and stuff, it's good, right?
This is all because they're trying to have more stuff in here. I get it. And it's like, it's tough
I totally get it too.
Getting an additional like vendor on your vendor list, like not easy. Fine.
Yeah, exactly.
I'm not here for this. Like, so maybe we could have like a section, like the janitorial section or the marketplace section could be separate. Yeah.
We have to name this episode something janitorial.
Cleaning up the 20 chips that you want to.
We can name it the Custodial Arts.
The Custodial Arts. I like that. Yeah.
The Custodial Arts. There you go. That's the name of this episode. There you go.
I like it. Yeah, bring it on.
Custodial Arts. Yep.
Yeah.
That reminds me, the Breakfast Club. We can put in an image of the Breakfast Club. Carl is the janitor from the Breakfast Club. If you've ever seen that,
of course.
Anyway, if you haven't, that's movie of the week.
Come on, man.
Yeah, right.
Any kid who's had TBS in their household in the late 90s.
Oh, okay.
Saw a lot of Breakfast Club. I saw it in like pieces. I would see it like 20 minutes at a time.
Oh, okay. Yep. Anyway, my hero was Carl the janitor. John Kapelos, I think. John Kapelos played Carl the janitor in. Wow. The Breakfast Club. I even remember.
Did you just look that up, or did you remember
No. I know John. John Kapelos has been in lots of stuff. I think I'm pronouncing that correctly. John Kapelos.
Okay.
Yeah.
While you're doing that, I will call out Unmanaged 615, who's been very active on our subreddit. So thank you for that. We really appreciate all these links.
Yes, indeed.
Had a self-ordained chip of the week. T-Pick 6595. Instant disqualification because it's a TI part, and I actually haven't seen any TI stuff in stock in the last 3 years.
Okay, so we're boycotting. Okay.
Yeah, this is. I seriously, I haven't seen a single part in stock.
But come on, all those TI US fabs, they should be spitting them out.
Oh,
right?
Yeah. They'll be ready in about 5 years. Thank you very much.
Okay. All right.
Just make sure those tax breaks come on in. Come on in. Get on down to Texas. Anyway. I think this is an automotive part, and it can drive a bunch of current per pin, 250 milliamps per channel. So it's a 595 shift register. But then if you want to drive some beefy current, I think.
Oh, hang on. Show me. I'm trying to find the link for it here. Where is it? Chip of the week. There it is. Got it. Yeah.
Yeah, and I think that Unmanaged said that
T-Pick 6595. I love that they keep 595 in the part number. Is it the same pin out?
I think so. Yep.
Oh, a 595 with 250 milliamps per channel. This is life-changing.
This is a big one. I have to imagine, so this is an automotive part, which means there's probably cars on the road, like just cranking current through these things right now.
Yeah.
It's interesting. I don't think there's any stock.
Right. So it's basically combining a 595 with a 2803 driver. Is that basically it? A 2803 open drain driver.
Oh, yeah, this isn't a standard. This is a 20-pin part. So, yeah, this isn't standard, but yeah.
Oh, no. Yeah, okay. It's not standard pin out. Oh, I'm triggered. Have a look where the VCC pin is. It's pin 2. I'm triggered.
Oh, my.
I'm triggered.
Right below What is the reason for that? Oh, that's interesting. Because there's ground on all four corners.
Because this is a power device, right? So you can't. Yeah. I mean, you can't feed in the power. Well, these are open drain, right? So they drain to ground. That's hence the name. They drain to ground. So you can't just have one ground pin, right? Yeah. So that's why they have 4 ground pins.
So internally too, these probably aren't even are these even bond wires, or they're just like huge?
Oh, they're giant bond wires. They would probably have. If you decap this, you'd probably find different diameter bond wires for the ground pins.
Yeah,
that'd be my guess.
You call one of the decappers? Do you think they can get a hold of one of these?
Yeah, or 4. but you can say, when you got 4 of them, maybe you can get away with the standard size bond wire. But it wouldn't surprise me if they had thicker bond wires for the ground.
Yeah.
Because you've got 8 drain outputs, right? With 250 what's it? 250 milliamps. Is that each output? What is the? Let's go to maximum specs per channel.
1.5 amps. 1.5 amps total, I think.
Pulse drain current each, and can pulse.
Oh wow!
And can pulse to 2 amps.
What the hell are they doing with this thing?
It's a beast.
It is a beast.
Wow.
Is there an application section? Low power consumption.
I can tell you a million bloody applications for this. It's combined in a 595 shift register with the ULN 28003. The number of times I've seen 595s, or done it myself, 595 shift registers with latched shift registers.
You're just tying them together to the output
with a transistor driver. Yeah, it's like
wow. Oh, so then these would actually be driving even like so you might be driving like an H bridge with this sort of thing even?
You could be driving relays. No, because it's an open drain. You wouldn't be driving a H bridge with it, but you'd be driving relays. You'd be driving solenoids. So that's why in a car, solenoids and valves and things.
Okay, I'd feel a little better about that, I guess. Right. Shifting into like as long as it's not like controlling the engine or something.
Right. Well, and this is why it's a 595 topology, because the 595 topology is a latched topology. So you shift in the data, then you latch it out. So you don't get any problems when the data actually is shifted through. It doesn't, you don't get any changes on the output until you go, right, I've shifted all my data, then I'll latch it to the output and it all gets latched in one go. Otherwise, you'd be relays and solenoids switching off and on as you shift data through this thing. No, can't have that. So, so that's why they're using 595, because it's latched. It's great.
So like really, really big 7-segment displays, that also
really, really big 7-segment, kick-ass 7-segment displays, 250 milliamp jobbies. Yep. Wow.
With like incandescent bulbs.
Yeah, with incandescent bulbs, yeah. Gigantic LED strings, Yeah. Wow. Exactly. And output, what's the maximum voltage? 45 volts, is it? Hang on. Yeah, that's
Wait a second. Wait a second. EEV blog, Dave Jones, has a Nixie driver circuit using a TPIC 6B595. You've used this in your circuits.
Just before you said that came to my mind. I thought, did I use that in my Nixie? But, because as I said, it dawned on me, as I said that 45 volt thing, as I said that, I went, ooh, could you use that for Nixies? And then it dawned on me, oh shit, I think I used that in my Nixie driver. Yeah.
I've seen some of the schematics.
How did you find that?
I just typed in application circuit and TPIC 595 application circuit.
In circuit
and then I did what every good double E does and turns on images, and then there was the Nixie tube, and I clicked
that. That's great. Yeah.
Yeah, we'll link in the video. There was a couple of videos about that, right?
Yes, yeah. It was a whole series.
Yeah.
Cool. Yeah, it was a whole series. Yep. Whole design series, like 5 parts or something. And I laid out the board. Cool. So I did, I did schematics and board layout, and I did how to, optimize your schematics and all sorts of things in there. So it wasn't just actually designing the board. It was like a whole process of designing a thing start to end. And I even used that as an example for human auto routing versus human routing versus auto routing. So I was, yeah. That was my example.
You didn't do KiCad on this one. I remember you picked up KiCad on one of these projects.
No, I did Altium. I don't think did I? I don't know. I'd have to watch the video
that was the it was a computer. It was like a 4-layer computer.
The 4-layer. Yep, the 4-layer TTL computer. Yep.
Yeah, that's right.
I think someone may have converted the Altium file to KiCad, but I don't think I got around to running the auto router on KiCad. Anyway, that was years ago. I could use that as an example again, because I thought it was a really good auto router example, because, like trying to fit this on a 2-layer board was kind of, not that easy. So, yeah. Anyway, so that's why it's familiar. It's slowly dawned. Look, I've done so many videos. I mean, come on.
I know.
Like, how many years ago was that? Was that 4 years ago that I used this chip?
I think more than that.
Yeah, right. Yeah. No, about that, maybe. Anyway, it's a buck. It's $1.10 in 1,000 off quantity, and obviously I could get it back then. I don't know if you can buy it now, but back then, I could get it. And I think from memory, the 45 volts was just enough for the Nixies. I think it was just enough. So, yeah.
Another commenter on our subreddit said bubblegum tap shoes. It is entering the zeitgeist here, Dave.
Right.
I did find a couple SOIC variants. This is Digisa, a couple of variants on Octapart from authorized distributors, but most variants are out of stock or very, very low.
Yeah.
TI parts. Come on.
I'm sure.
Who's buying TI parts these days? Nobody.
Well, all your Apples and your Toyotas of the world are.
Not you, not me. That's
exactly, because they prioritize their major customers. They're still churning them out by the billions. But
no doubt. Yeah, just back of the line, buddy.
You just ain't paying enough. That's all.
That's right.
Yep.
Oh my gosh. You know what we should do? We should do like a sting operation where we call up some of these bogus ass distributors and be like, I would like to wire you as much money as you want to charge for these bogus ass parts.
Right. And see who they're stealing them from.
Utmel Electronic. I mean, they're surely just like desoldering them and then cleaning them up and
right, and then sort of cleaning up the pins and making them look new, are they? Do you think?
That's got to be really paying off right now. Okay, Utmel Electronics. Who knows what the hell this thing is, right? It looks like a legit enough site. UTMEL.
What?
You know how much they're charging for?
Send me the link.
They have, so they have a decent looking website, at least. I'm saying it's just a bar for that sort of thing. Sorry, let me find my chat thingy. Okay, so, you go to the site, like, oh, okay, this kind of looks like a...
Utmel. It kind of looks semi-Atmel official, doesn't it?
It looks kind of official. It's nice design. I mean, it's a nice design.
So do they only have Atmels, or do they...
This is the T-Pick 65595, right?
Oh, so this is sorry. Yes, it is. Okay.
Yeah, they're showing that part, right?
Yeah,
you said it was $1.14. How much is it showing on this page for?
$15.
$15.
$15.
But they have 907,000 in stock, apparently.
What?
It's just, that's what they said. They have 907,000 in stock.
907,000?
Not they just...
1,000 of quantity at $12.
Yeah, I'm sure what they're really saying is, if you pay me $12 per 1,000, I will find 907,000. I will find them.
Parts. Yeah. They probably don't have them. Yeah.
No, yeah, of course. Right. I mean, but there is no.
Go find them.
I mean, this is just crap. There are so many shady places and they're coming out of the woodwork now too, right? Yeah. There's just broker groups. They're
Yeah, they've just sprung up
I'll complain about the DigiKey marketplace all day long. But you know what? I'm still going to buy from DigiKey first and foremost, or Mauser, or just, even Arrow if they ever had any stock of anything, which they don't.
The DigiKeys and the Mausers of the world haven't been up in their prices, have they? Or am I wrong?
No.
They're just saying out of stock.
They're drifting up. They're drifting up. But
but they're not charging suddenly 10 times the price just because they have stock, right?
Yeah.
Right. Yeah. Okay.
JAK Electronics, JAK Electronics. This is like the exact same page design. I bet all of these, they're probably just churn. It's all the same people. I bet.
Yeah.
This is like me sounding like conspiracy but I just don't believe any of this. This is just, there is so much incentive for gouging and for scam artistry. Totally. It's just this one. Sorry, JAK Electronics. Guess how many they have? 907,620. Wow, isn't that surprising?
And if I go to the DigiKey. And if I go to DigiKey for the exact same part, the TPIC 6, the DWRG4 or whatever, 0 in stock, 0 marketplace products from Rochester. And Rochester are the biggie that specializes in surplus parts, right? Sure. So where the hell are these little no-namers? getting them from. No,
Yeah,
it's all
where are they
bullshit.
digging them
They're
out of?
just,
Yeah.
yeah.
I
And
could tell
if they can't, they'll simply refund your money, right?
these are
So
vapor chips. These are chips made of vapor.
vapor chips. All right.
It's just a bit frustrating.
Well, there you go. So our chip of the week is officially unobtainium.
Yeah.
Yep. Because I don't believe that they can get them for you.
No.
I don't. 907,000. Come on.
907. I mean, how many did you put on your design? There was like 6, 8 on yours?
Yeah, 6 or 8 or something. Yeah.
So 8 of those would cost you $120 in just these driver chips before you stuck a single Nixie tube on there?
Yep.
I don't think so. I don't think so.
I paid $1 at the time. Yeah. I paid $1 each. Yeah. It's nuts. God, I wish
really
I'd bought
frustrating.
If I'd known, I could have cornered the market.
Yeah, your crypto's looking real dumb now, isn't it, Dave?
Yeah, it is. Dumbass. Yeah, bloody hell.
You had gold under your nose and you bought fake gold online.
Could have been a 100-bagger. Easy.
Could have been.
Man. Or a 10-bagger at least.
Go back in time and just tell yourself to hoard parts more than you already were.
Unbelievable.
Hello, young Chris. I'd like you to tell you which stocks to invest in and which parts to stock up on.
Oh boy. There are some companies that will pay anything to get these chips.
Of course.
Guaranteed.
If your line is down and you're if you can't sell the $30,000
product,
car,
exactly.
Yeah, exactly.
Yeah.
Like it's really like, how much does this part matter to the overall design? And how much are you going to lose if it sits half finished on the floor of your your manufacturing facility? Because there's a lot of cost to that too, startup costs and shutdown costs, and we got to talk about something else. I'm getting depressed, Dave. I'm really getting depressed.
Well, good thing we're near the end of the show.
We are.
What
else can we talk about this? Is there anything happy here? Oh my God. Okay, you got to look at this one.
Okay.
From oscilloscope to Wireshark. This is some bonkers stuff. This is mattkeeter.com. Matt works at Oxide Computer. And you may recall Laura, who was on the show a couple weeks ago, 6-7 weeks ago, also works at Oxide. She came on to talk about the LPC 55 S69 or whatever the part was that had a security vulnerability. Oxide makes servers. Look at this thing. So they are basically they soldered a differential probe on the outside of, I don't know what the hell that chip is. Is that a FPGA?
Is that a homemade differential probe, or is that a commercial differential?
I literally have no idea what this thing is. I've never seen anything like this before. It looks like a flex circuit with a control impedance, traces on it.
Yeah.
Differential probe. Yeah. And basically they bodged wired it onto these pins, and then they're probing gigabit Ethernet.
Yeah.
And so they're putting the gigabit Ethernet into an oscilloscope. And then finally, they have what was the size? It's a 100 megasamples it could collect 100 megasamples at 1 terasample per second, which multiplies out to 100 microseconds of data, which means we could catch. So all of this is to catch 1 to 3 UDP packets.
Oh, can't you get, that's nuts, but you can get specialized tools that do this, right? You can get specialized Ethernet packety capture-y tool things, can't you?
I guess. I mean, it's probably going to be like, what they're piecing together here is probably the same kind of thing as the specialized tools.
Right.
But then, so basically, once you capture that though, then they're sticking it into Wireshark. And like, I don't know. I didn't even get why they're troubleshooting this sort of thing.
I'm going to say, what's the end purpose of doing this? Are they hacking something? What are they?
No, they're not. I think they're definitely troubleshooting, because what they're doing is then they're basically doing a data dump into an oscilloscope. Then that data dump, they're then converting. They do like some scripting around it, and then they stick it into Wireshark. And Wireshark basically reads out all the bits, right, which they basically captured. If you go about halfway down the page here, they kind of show how they're capturing these packets, because they're differential packets that are not even like super square.
Yeah.
And then they capture the data, right? They put it into binary format. Mm-hmm. They process that binary format. They basically then say, okay, well, we know that this character is an A, this character is a 1.
Yeah.
And then they piece the packets back together. They then zoom out and they say, oh, here's a frame, basically, and this is the UDP packet. And then they get 3 UDP packets, but I really don't know what they're doing with that then.
Right. But isn't Ethernet multiple differential pairs? I only see probing one differential pair here.
Yeah, I didn't get that either
Do you
because they
not?
also showed further down. They have a little diagram where they show the QSGMII, which is basically the. I think this might be the after the phi. I think that might be what we're looking at here. So I think they're probing on the QSGMII, which I think is the kind of the collated from multiple pairs, because it's 4 pairs for
Oh,
quad.
okay, right.
It's a quad for gigabit.
Okay.
And then,
right.
So the link between the switch and the phi is QSGMII, quad serial. Oh yeah, there you go. Quad serial gigabit media independent interface. And basically, that's between your Mac and your phi. It has this kind of like
Got it. Yeah.
format to talk, and it's a very high speed bus. That's kind of the way to think about it.
Wow.
So basically, yeah. So then they decode all this stuff, they piece it all back together, and then they get a UDP packet or 3 out, and it's just like, holy crap, that is, because the reason, it's actually interesting because it's like UDP packets aren't that big, right? It doesn't take 100 megabit or whatever they said it was 182 megabytes of information that goes onto a USB stick that they then stick into a computer. However, when you're capturing all the resolution on, the squigglies on all of the signal itself, and then you have all of the meta information around it as well, that's what starts to really add up, I think.
Right. Yeah. So they're just doing this because they had a problem and they had to debug it?
I think so. I think basically
well, that sucks ass.
their phi is getting a certain signal, and they're not getting that expected signal at the rest of their board. That's what I'd have to guess.
Okay.
Yeah, I guess it even says on the board 5.4, right? So they basically have. This is just insane, though. Basically,
my only experience with this is we were running gigabit Ethernet, and I was doing FPGA BERT testing, which is bit.
Yep. Error rate. Yep.
Error rate testing in the FPGA on the gigabit Ethernet board that I'd done, and but I didn't write that code myself. I just integrated it in. Somebody had already written the BERT software for the Xilinx FPGA, and then I integrated that in, and it just sort of worked. So I was doing the bit error rate testing, so you leave it there for a week and see how many errors you get over a week or whatever.
Yep.
And it just, accumulates and captures and stuff like that. But yeah, wow.
Oh my God. They do it all with a lookup table too. Oh my God.
That's painful.
You go from a 10-bit code group to the actual code group, and you just need a huge lookup table.
Yeah.
And then they literally do a pattern match, and then they label it as like D00, D11, D10. Oh my God.
Okay, I am definitely going back to my 74 series logic. Thank you very much.
I think that might be a good place.
I think I'll just stick with that.
Find some refuge, huh?
Yep.
Oh my gosh.
Yeah, it's so painful to work on stuff like this if you've got problems. If it doesn't work and you've got to debug it.
You know what? I think that's right. And this is what so like I mentioned before too, I'm not doing much, I've been doing more code and stuff like that. But even the stuff I've been doing, Dave, like, it's so high level, like
totally.
The amount of like libraries that are underneath like all of these things I'm doing.
It's it isn't kilobytes of code anymore. It's hundreds of kilobytes of code just to do basic stuff. Right? You need these micros that are running code you've never, you couldn't even believe. I've seen things you wouldn't believe.
I think that's what it really comes down to. It's I've talked about the 3 a.m. problem before, right? So like what happens when something breaks at 3 a.m., right? Yeah. And the more you know about the underlayers, the better off you are. But it's getting to the point where like I don't even know. Like, so
you're screwed if you get a problem like we're talking about here with this Ethernet thing. You're absolutely screwed. You do not have the tools to debug it. Yeah,
right. Yeah, and I think basically you have to assume it's not that stuff. I think that's one of the important tenets. But
I've come a guts there.
Sure, but I think you have to kind of do. It's like the Sherlock Holmes. You have to kind of like prove everything else.
Right.
Couldn't possibly be it.
Right.
It must be something under the hood, right? I've been thinking about this because I just saw, a Jetson Nano kind of thing, like an AI vision processing kind of thing, and just like the layers of abstraction that are just on top of that, so you have
incredible.
A screen talking to this super high-powered micro with all these layers of software, and it's just like, if something goes wrong, I'm gonna just like throw it in the trash and buy another one because what else?
Totally.
What the hell else am I gonna do?
Exactly.
I'm not even doing that stuff. So
yeah. Well, at least with my 7.4 series logic, I can get out my old Tandy logic probe and I can look
Yes.
at whether or not the lead goes red or green.
Yeah.
Yep.
Yep. I remember one of my old coworkers. He was really into building his own 8-bit computer. I think I mentioned him on the show before.
Right.
He was building his own 8-bit computer, and I think it was a little before Ben Eater had started. But Ben Eater, people that I love Ben Eater stuff, and Ben's popularity engine.
Oh, his videos, very in depth.
I mean, they're so good, right? But but just kind of like that. Well, why do people like doing that? And it's because you can literally get your arms all the way around.
Yes. You can see the bits shifting and the LEDs, and
exactly.
if you want, you can put a LED on every line and then simply slow the clock down to freaking DC, and you can watch as every single bit shifts.
Yeah. Yep. Exactly. And as another link to end out here, we have James Sharman's "Will It Run Doom" on an 8-bit pipeline CPU. Another great channel.
Come on. Yep.
Really great to watch.
Come on.
Great video. So go check that out. I won't spoil it.
Yeah. But you're probably too young for this, but I can remember when you had 4 major tools, and one of them's vanished. Okay, multimeter. Well, 3 actually, not including power supply. You had a multimeter, you had an oscilloscope, and you had a logic probe. Okay.
Logic probe, like not a logic analyzer?
No, not a logic analyzer, a logic probe. You don't even know what I'm talking about, do you?
I don't know. Yeah.
Oh my goodness! Look! Oh,
there's some video content for you here, Dave. Do you have a video about it?
I tweeted a photo of the logic probe the other day. Look, here we go. Logic probe. This is what look. You can buy them on Amazon. You can buy an Elenco probe on Amazon. Here it is. There you go.
Yeah, okay.
Logic probe. Right?
Yep.
That is a logic probe. It's a probe you hold in the hand, and it's got a TTL and CMOS button, usually old school, and it's got red, green, and yellow LEDs on it, usually. Red and green tells you whether or not your signal on your probe is high or low, and green will be a pulse thing, so it'll have a pulse stretching circuit in there. So it'll capture like a brief pulse, and then it'll flash the LED for half a second. So that, there's some sort of pulsey thing happening on that thing.
Got it. It's before you get out your oscilloscope, you're saying?
It's before you get out your scope. Yep.
Yeah. Okay. All right.
And you can just do an amazing amount of it's just gone. Who the hell uses a logic probe anymore? But that was one of the 3 major tools. Has vanished.
Sure, but that was because oscilloscopes are so expensive.
Oscilloscopes were very expensive. Yeah, exactly. No, they're still expensive.
This is the combination of things, like you ever seen that thing where they do like the iPhone, they combine everything down, they show like the desk of stuff.
No,
everything's in a scope these days. You can do a shit ton of stuff.
Everything's on a scope. Okay, so scopes have come down in price, and you get like little toy ones, and you can get toy
virtual
ones
bench,
for $50. Yeah, you can get all the virtual bench ones, all right. But anyway, the reason logic probes died is because you can't use them on microcontrollers and other stuff, right? And when you were designing with actual discrete logic, you could simply probe around. You had your schematic, and you can probe the pins because they're nice big dip chips, right? So you can put the probe right on there. Sometimes you slip. And,
you're waxing nostalgic here, but I am not. None of this is hitting me in the fields
exactly.
Right here.
Whereas I'm sure there's lots of people out there. Whereas because you had to. This is before microcontrollers, right? You simply didn't have a choice.
But that's not, like I said, it's not hitting me in the fields because
no, it's not.
I don't want to do that stuff.
Why? It's great. You missed out
I like
on
the modern stuff, though.
Nah. Give me a logic probe. I've still got my logic probe.
I mean, Dave, here's the thing. I have a circuit I just built on my desk that has more sensors communicating over cellular
than the freaking Apollo moon lander.
Yeah, I mean, this thing is like, it's a beast. It's a legitimate beast. It's got 8 sensors. I built it. I stuck it together with like commercial hobbyist level hardware.
Yep.
And it's basically like a mini product now. And like, I could do that. What can the logic stuff do?
I don't know. I can give you a countdown timer.
This is what you should do. This is early April Fool's joke diet. Mark my words, folks. A cellular modem built out of TTL logic. That's what you should do. Right. And it looks like like when Doc shows up with like the vacuum tube op amp. For the DeLorean. Yeah, it should look something like that.
Right. Got it. Yeah. Sounds good. Anyway, logic probes. Yeah, an everyday use tool that simply vanished. Everyone had a logic probe. You were nothing in electronics if you didn't have a Logic Pro back in the 70s or early 80s, early to mid 80s.
Yeah.
By the end of the 80s, microcontrollers started, becoming a thing, and it kind of
Did you know that on August 18th, 1972, what was that date in electronics history?
Which date?
August 18th, 1972.
Nope.
That's 50 years ago today. That's how long ago you're talking about here, Dave.
What?
You talk about the 70s and electronics. That's 50 years ago, man.
Oh,
50,
right.
50
Okay.
years.
Sorry. Oh, right. I thought
That's
something specific happened on that date.
No,
okay.
No, I'm just saying that's the day we're recording. If people don't get this, we're recording on the 18th. Yeah. 50 years. Of course it changed in 50 years.
Yeah.
Look at the Computer History Museum. Look how much changes in 50 years. Good riddance, Logic Probe. Good riddance.
God, no! Come on! Oh, the Logic.
Come on, man.
The humble Logic Probe. I don't know. And you got to remember back then, right? Even if you had an oscilloscope, it wasn't. You had none of this capture rubbish, right?
Mm-hmm.
It wasn't a digital scope. You couldn't capture shit.
No. You had to take a Polaroid.
Yep. Or you have to, turn up the intensity and, I think I saw that pulse, Whereas a Logic Probe it'd have that pulse stretcher in there. And then, can we talk about logic injectors?
I think what we need to do.
Same thing. You would have a Logic Probe and you'd have a logic injector.
Here's what I think we need to do. I think we need to get like a Bill Hurd back here or someone else who was like really into this scene. Cause I'm just like, I'm not going to be able to give you anything back here.
Right. I guarantee you he was using
I guarantee it as well. Yeah.
A Logic Probe when he was working on the Commodore. Yeah.
And I'm sure there's other people, but I'm just not that person.
No, because you're too young.
I'm a spring chicken.
No. Anyway, a Logic Pulsar, a Logic Pulsar would have big grunty transistor output.
We're going to end the
show. We will. And a big grunty output driver which would override logic pins. Right? So even in circuit, you could go, no, I don't care if I'm already feeding in a clock. I'm going to feed in my own clock and I'm going to override. Boom. And big thumping transistors on the output would override the piddly little TTL output you're driving it.
This sounds healthy for a pin. Yeah.
Oh, it's great. TTL's robust, Yeah.
Right.
No worries.
Dumping current through protection diodes.
Logic Pulsar. Yep. And everything was 5 volts too, So unless you had 4000 series CMOS, then you could go from 2 to 15 or whatever.
Dave, I'm sure that there are some people nodding their heads right now.
Yeah.
All those heads.
All 10 of you. I salute you.
No. All those heads, they probably have some gray hairs on them. I'm just gonna make a prediction there.
Unbelievable. Anyway, that's our show for this week.
That is our show. I'm sorry if I offended anyone about old comments. I love you all. Catch you next week.
Catch you next time.